example 1, graphing exponential growth functions. And this is of chapter 5, section 1. So we're going to graph this function 2x. We're going to find its domain, range, y-intercept, asymptote, and end behavior. So we can make a table of values and then plot so that we can pick any x's that we want to, and we can plot this. You could also put in a graphing calculator, but once you identify some key features of these types of functions, really, they're pretty easy to graph. We kind of just need 2 points and this asymptote that tells what line we cannot cross, right? This asymptote is a barrier. Specifically, this one is a horizontal one that we cannot cross. We get close to, but we can't approach it, because when I do, say 2 squared, that would be 4, right? So I could plot that 1, 2, 1, 2, 3, 4. I plug in 2, 1. I get 2, so 1, 2. Then I plug in 0. So as I go down, aren't I just dividing by 2? So 2 divided by 2, wouldn't that be 1? And then negative, well, what does a negative do? Doesn't a negative just flip that base? And now it's a positive 1, so I get 1/2, right? And then 2 to the negative 2 would be 1/4. And then 1/8. And I keep getting smaller and smaller and smaller, but I never seem to be able to get to 0, right? So that's called the horizontal asymptote. I don't get to cross the x-axis, y equals 0. So I have a barrier there. But after that, I just keep going up. Aren't I just multiplying by 2? So I'm going to get larger and larger and larger and larger and larger. So what can I plug in for x? Can I plug in any positive number and any negative number? So my domain is all real numbers. Well, I notice that my y values don't get just are above 0, right? And I keep going up. So my range is y's are everything above 0, not including 0, because I don't actually touch 0. Y-intercept, I looks like a cross right there at 0, 1. Our asymptote we said was y equals 0. We don't cross that. And end behavior, as my x's go to the right, is my graph just going up? F of x is just going up and up and up and up. As I go to the left here, as x approaches negative infinity, I seem to get closer and closer to 0, right? But I don't touch it, okay? So there's how you can plot it. Basically, anything that's being raised to an exponent, I really want that exponent to be 0, because anything raised to 0 is 1. So that's kind of easy to graph, 0, 1. And then the next exponent to pick is 1. Best exponent to pick is 1, right? So 2 to the 1 would get me whatever that base is, right? And then once I know that, I know it's going up from there. And then I just need to know that asymptote. What line do I not cross? Well, I can figure that out by looking at the general equation and saying, okay, after I raise something to a power, right, then I may be multiplying by something. But after that, I always add some constant, right? Maybe a positive, maybe a negative. Well, that is always going to be your asymptote, however you want to say it. So that's going to be always y equals k, whatever's being added after the exponent, right? After the exponent, after this is taken care of, that's going to move it up and down. Okay, so then if we look back at this one, here's our graph. Well, what if I did this, 2x minus 2, right? So then to get an exponent of 0, don't I, excuse me, don't I need to plug in a positive 2, right? So I would need to plug in a positive 2. Well, that's going to move this graph over 2 to the right. So even though that's a negative 2, I would plug a positive 2 in order to get a 0 as an exponent, right? So it's going to move it 2 to the right. So anytime you have a negative right here, that's actually going to move it the opposite direction. So if I have a x plus 2, it's actually going to move that to the left 2. And if I have a negative, that's actually going to move it to the right 2. Okay, so that number with the exponent is always going to move it left and right. Then if I have a number in front, okay, where's that at? Is that in here? Maybe that's not in here, sorry. Scroll down here. There we go. If I have a number in front, if I'm multiplying and that number is negative, isn't that going to flip over the x-axis just like quadratics, right? That's going to flip over x-axis, right? That's always going to flip over the x-axis. And then if I have a number in front of that, like 2 or 1/2, that's going to stretch it or shrink it, right? So if it's multiplied by 2 out in front, like it's 2 times 2 to the x, right? That 2 in front is going to make it grow faster than without it, right? Or if it's a fraction in front, 1/2 2 to the x, then that's kind of going to shrink it and make it a little bit wider like that. Okay, so those are kind of what the things do, those three things. We have a number out in front. If it's negative, it's going to flip it over the x-axis. If we have a number in the exponent, it's going to move it left and right. Number at the end is going to move it up and down. So that's basically it at how you graph and then identify the domain, range, y-intercept, asymptote, and end behavior.